So this is the eighth assignment, and the focus of the assignment is to introduce testing the user interface. Right? It's a chance for us to apply some of the things that we've been discussing for the last couple of weeks, and in particular, we just finished discussing earlier this week of how to test the user interface. And we saw that there are some things that are very similar to the way we test components in general. Right, we refer to them as unit tests, and that, like the name suggests, we test it as a single unit, independent of what environment or what framework or of what dependencies this particular unit depends on. Right? So we typically try to eliminate any of these dependencies so that we can test the behavior in isolation. So this assignment asks you to do just that. You'll be asked to refactor some of the components that you developed in earlier assignments and to isolate them so that you can test them individually. So there's really three parts to this assignment. The first three major things that you'll be asked to do is to revisit some of the components that you might have written earlier. Again, if you already achieved this and implemented this as stateful or stateless components, then you're done. You're halfway done, right? If you're using Redux, which was not covered in class, and if you feel comfortable with that technology, then you're pretty much done with this part, and you can just check it off. If you haven't, we're asking you to refactor the component that you might feel more comfortable with, whether some details components or some summary list components that you feel is the most finished and complete component, and to refactor it so that it becomes a testable component. I mean, it is testable now. It's just that it's so much more easier to test if it's implemented as a stateless component, and it has no dependencies with the RESTful service, and it doesn't have any dependencies with state management and event handling. So ask you to isolate components into unit tests, and then to mock all the dependencies that associate to that component, such as the services, state, and to mock all those dependencies using the techniques that we discussed earlier this week. So that's the first major part of the assignment. The second part of the assignment is a follow-up to what you worked on in a previous assignment that I had asked you for the components that you were implementing in a previous assignment to create a user acceptance test, right? And the intent in this assignment is to revisit those user acceptance tests and execute them, right? Basically, you're going to meet as an organization. You're going to identify which are the components that you feel are the most complete, right? That you feel more confident that are feature complete, and then amongst yourself decide who's going to test who, right? So ideally it would be that you're testing someone else from some other team. I guess the easiest thing would be that Team B tests components from team that were implemented by Team A. Team C tests component implemented by Team B, and Team A tests component implemented by Team C. Right. So each team tests some other team. Make sense? We're asking you to identify one component. Just focus on that one component, and to go through the user acceptance test. Perhaps do it together with your peer. Actually, no. Ideally, you do it by yourself. You do it by yourself, just only reading the user acceptance. We want you to put on the cap of the user of the quality assurance engineer. The quality assurance engineer typically might work for some other team in the organization, right? That has their own reporting structure. They might have or you might have other teams where you have a QA engineer assigned to your team. Right? It depends. Each team is different in different organizations, right? So you might already have a good rapport with your QA engineer, or you might not even know them, right? That they belong to some other organization, and Ideally, there's not too much rapport in that the QA engineer can be objective and test your application, with rigorousness. They'll be blunt and they'll be very very objective and not have any feedback from you that might might impede their work. So try to follow the user acceptance tests that were written for you. Always with some open-minded and some rigorousness. And question the user acceptance test. Don't assume that the user acceptance test is written correctly. It might be written incorrectly, right? Or it might misstate what the original requirements were, right? So make sure that as you go through, that it is accurately capturing the requirements, okay? That as you're going through it, it is indeed representative of the requirements. Even then, feel free to question the original requirements, all right? If you do find some critique that the requirements might have been better described, or that there's a missing requirements, or that a better implementation might have been something else, or there's a nice to have that is not there. Feel free to record any and all deficiencies that you see in the product. Okay, take ownership of the product. If you were the real user of this application, what would be your point of view, right? And be as detailed as possible, even if it's just a look and feel thing that you don't like. Maybe some inconsistency. Maybe that most of the fields have a particular look and feel with rounded corners and a particular font, and then you find some other elements that do not follow the same look and feel. Maybe you have your square corners and they don't have the same highlighting or whatnot. Point that out. As a defect, right? That perhaps I'm hoping that most of them might be very low level defects. And at some point, the project manager and the product owner are gonna go through all these defects and assign them to be addressed at a particular sprint. Right? They're gonna go through it and they're gonna give them priorities. Some of them are very low level priorities, things that are nice to have, but we don't really have time for that, and things that are very top priority that need to be addressed right away. So be as rigorous and detail oriented as possible, also it might be that a particular component might have some features that are not implemented, but are not necessarily the responsibility of the person who you are logging the bug against. Okay, that's okay. Right, that's the responsibility of the Scrum Master and the project manager to decide really who should be addressed, who should be targeting this. Right? It might be also that it's not that it's a defect per se, but just the work wasn't yet scheduled for any of the sprint. For instance, you might be looking at a summary view, and there's a missing pagination, or there might be a missing filter or whatever, right? As far as you're concerned, it's a defect, right? It's a missing requirement that was due, a couple of sprints ago, and their specifications are clear that they should be there. So don't assume that your buddy tells you, oh no, don't log that because we know that, we didn't get to this sprint. I mean, you're the QA engineer, you're not part of that development team. The specs say that they're supposed to be there and they're not. Log the defect. Okay, it'll be the responsibility of the Scrum Master and project manager to know that, yes, I know we didn't get to this. It's part of this upcoming story, and they'll either close it or say that it's a no-op. We're not going to fix it because it was never implemented. So it's not really a defect, but it's not your responsibility. Yes. Your responsibility is to identify everything that is missing. Okay, everything that according to the specs, it should work this way, and it's not. All right. The third part of the assignment is to start automating the process that we've been using for the last couple months. Right. Up to this point, we've been compiling and building and packaging and doing all the deployment ourselves manually. We want to automate that as much as possible, right? So that every time we do a check-in or somebody merges to master, right? We want to have tools that automate the entire production pipeline, right? That every time somebody merges something, that we kick off a build, and that automatically checks out the repo, does a compiling, runs the tests, packages and deploys automatically. If there's anything wrong with that process, we want to be notified. We want to fail the build and leave production clean. We don't want to, we don't ever want to push something that is broken to production, right? So we want to automate the process that catches this and then notifies the right people. And says, hey, something's wrong. Come and fix this, right? Now these builds, these builds should always, these automated builds that we're going to be working for the next couple of weeks, should always be successful. It should be a rare occasion that these builds fail, right? And we should treat any failure of these builds as a rare occasion and as urgent as possible, something of urgency, right? That needs to be resolved immediately, right? That if we identify that these builds are, frequently crashing and not building, we need to address that right away, right? And see if we identify there's something wrong with the version of Java or the version of Maven or something's wrong. What's wrong with the build? We need to automate it and make if it's a particular developer, if it's a particular team, if it's a particular process, you need, as an organization, deal with it, right? And help the rest, whoever's responsibility of causing these builds to fail. We have to educate the person or the team and make sure that this does not happen. That truly is rare. If we let it go, these continuous failures, we might just tune out and start considering them to be just noise, noise that we're not going to do anything about it, right? So it should be treated as urgent, right? That these builds are failing. Right. So let's just look at each portion one at a time. So the very first part here is UI testing. So what we're asking you to do is again grab your best component that you feel most comfortable with, and we're asking you to refactor it in such a way that it can be easily tested. Right? Remove any dependencies with services, remove any state management, and encapsulate that in another container. And separate the concerns, right? So that only one component is dealing with state, and other components are only dealing with rendering, and other components are only dealing with access to the data service, right? So that each component only has one task, right? So we're asking you to choose one component, right, and refactor it, all right? Once it's refactored, we're asking you to start writing unit tests for that component. For that, you'll need to mock the data that you're going to test that component on. You already have lots of data that is being provided for you from your RESTful services, yes, for your middle tiers and whatnot. So choose whatever middle tier is appropriate. Maybe hit it with a get query, yes, and the JSON that comes back from that request. That's a good start for you to have some test data, right? That you can store it maybe in a local JSON file, and you can test that as a mechanism to feed your test harness, right? Now this mock data might be you might be several developers depending on this same data, right? Because you might be doing the details version of this, and somebody else might be doing the summary version of the same entity, right? So just work with this other fellow, right? Make sure that you coordinate amongst yourselves. If the data is good, if the have all the data that I need, just coordinate and make sure that you're both happy with the mock data. Same thing for the service. It might be that several folks, maybe even 2 or 3 developers, are using the same exact service. And some of you might be using so coordinate with them, right? Maybe break it up amongst yourselves, and each one of you can grab and mock one of the many service endpoints, right? Maybe one of you does the 2 finder methods. Maybe some of you does the create and the update. Another one does the delete. So just work it out amongst yourself. Which one wants to mock which part of the service? Make sense? All right. So again, one service. Usually the service that you need for multiple. So yeah, this one service typically will be used by multiple components, right? So you'll need to. So this will give a chance for multiple developers to work together, collaborate, and not trample on each other's code, right? So you're working on a shared resource, and you'll have to work with your own feature branches and merge onto each other's branches. So that will be challenging. So once you have the service mocked and the data mocked and the component is stateless, and you have applied the separation of concern principle, we're asking you to actually create the unit tests. Now, we talked about 2 types of unit tests. One using the snapshot testing technique, that basically you mock the data and you have it rendered in an environment, in a simulated environment, and then you compare the actual DOM representation in the snapshot with the expected implementation of that same snapshot. And so we're asking you to apply that technique, that you generate the initial state of the DOM, right? And then if also to simulate events on the elements, maybe click on a button or type something on an input field, simulate those events, and then capture the mock data, the snapshot, right, and verify that the snapshot matches what your expected values are. And these snapshots should be included, checked in, pushed to the repository as just like any other piece of source code, right? So that they can be reused in later sprints, right? So that if you break something, the test will capture this and let you know if there's a regression. So that's snapshot. For DOM testing, we also want you to exercise the techniques that we looked at earlier this week about being able to identify that the layout of the application is programmatically correct, and that if you asked 3 items to be rendered, that you would expect there to be 3 rows. Right? So interact with the DOM, retrieve to see if indeed 3 rows were added and rendered, right? And validate it against that the expected and the actual values. Compare them and report them, and assert whether they are valid or not. Okay. Let's see. Also for the middle tier, before we left for the break, we had asked you to write unit tests so that the coverage, the code coverage was at least 80%. Probably many of you or most of you had much more than 80%. We're going to gradually increase that to 85, then 90, and all the way up to 95 later on in about a month at the end of the semester. If you already are at 95, right, which probably most of you are, you can just skip this part and just notify, let the TA know as part of a story that you have already completed this. Okay? Yes.
This assignment says that all new code should have had a coverage of 80%. I don't think, from my understanding, the assignment didn't say that all of our code had 80%.
Is that what we said? I forget. Okay.
I mean, by all means, like if that's the assignment, like.
No, if it's not what it said, then we'll stick to that, and we'll have better verbiage. Yeah. So probably what we'll do is leave it at 80 perhaps, and then just ask that that everything is 80%. Yeah, that was my original intent.
Okay.
But that's fine if there's miscommunication. Right. So that's a middle tier. For the user acceptance, as I mentioned earlier. So meet with coordinate as a organization, write some stories for you to do the acceptance testing, and document your process for user acceptance in that new story, and link any new bugs that you have created because of deficiencies you might have found in the behavior of whatever you are testing. So you should test at least one component. So each developer should be testing at least one component, right? Meaning there's 3 components per team. So each team will be testing 3 components, and somebody else will be testing 3 of your own components, right, implemented by your own team, right, and so on and so forth. Again, be rigorous, be ruthless. Any nitpick that you might find, or better suggestion as how this might have been implemented, or even any complaints you might have, even from the existing requirements. Don't shy away from pushing back on the requirements. If you think the requirements might have been better captured in some other way, right? Feel free to complain about this as well. All right. This is the ownership should go all the way down to every single line of code, but all the way up to the original assumptions of the requirements. We're also asking you to do some code quality and code review to identify whether there's some technical debt that we have been accumulating over the last several weeks. If you take a look at the user interface that you're testing, and visit the entire stack. Right? Look at the services that were used to implement it, any controllers, any repositories, anything that you see that it's not up to par, that you don't like. Please record this as a defect, as technical debt that we have perhaps been accumulating over several weeks, that at some point we're going to have to pay down that debt. Right? We're going to have to come back and perhaps refactor, or even though it might be behaving correctly, right? There might be some shortcuts that the developers might have taken that are not a good practice. Even if it's just naming convention, even if it's a variable that it's it's a single character variables, certainly they have to be called out, right? Or any functions or signatures or any bad practice that you might identify. Okay. So yeah, call that out as well. The continuous integration, we have created a website, and we're asking you to please go in and create an account. And to capture in a story, in an organization level story, capture all members of an organization and the usernames that you use to create those accounts in Jenkins, right? And now the Jenkins machine that we have is not connected to the university. It's not connected to LDAP, so it's not going to verify that this is a CCIS account or not. Right? We're just asking you, please use the same username that you use for CCIS, right? So that just for us to keep it straight on who's who, right? Please use the same username, and just capture the username and capture all non-usernames, and copy them to a story for the TA to go in and describe there that you want the TA to create a folder for you. He will create a folder for your organization, right? And so all members in the organization are going to have access to that one folder. Inside of that folder, you'll be able to do whatever you want, right? But you won't be able to visit anyone else's folder and whatnot. Okay? The TAs will also have to configure credentials and your permissions and whatnot. You'll also be asked to for the Java repository that you currently have, you'll be asked to create a Jenkins file. The Jenkins file is going to describe an automated pipeline that is going to go fetch your repository. It's going to try and build it. It's going to try and package it. It's not going to deploy it. We'll do that next week. Right? We just want to make sure that the pipeline has access to GitHub. Right? That's going to be a little messy this week, right? As we make sure that the credentials are right, that certain GitHub accounts will be private, some of them will be public, and we're going to have to resolve that this week, right? So so please bear with us as we work through all these credentials and permissions and whatnot. Okay, but the end result that we want is the Jenkins pipeline connected to your Java repository and being able to download, compile, do a Maven clean install, right, and run the tests on Jenkins, and then notify you whether the tests failed or not. Okay. We're also going to ask you to add a simple badge, a build status badge to your repository, so that you can very quickly see if the master branch on your Java repository has successfully built the last time. We also want to be able to automate the fact that every time there is a check-in, every time there's a merge into master, that GitHub will automatically start a new build, run the test for you, and then do a deployment to Heroku. We won't do that yet this week, the automatic deployment. But eventually, we don't want to just blindly deploy to Heroku, right? We want to make sure that we don't submit anything to Heroku that is broken. We want to stop and abort the build if we do find that the tests are failing. We'll do that next week. This week, we just want to make sure that we can monitor the health of the repository. Make sense? Pretty good. As always, we have the planning. That you have to meet at the beginning of the sprint. Today, the sprint is going to end. We're going to start a brand new sprint. Okay, it's going to run for the next week or so. You'll have the same Scrum meetings every day for 5-15 minutes, either face to face or remotely, and just keep a log on your team meetings. Here we have just a list of deliverables and some of the reference. Okay. Any questions on the assignment?